you again for joining us for this week's Q&A. I have something a little different in mind today because I met this young man who I did introduce originally as hot. It's a hot young man who has a PhD. So obviously I was going to invite him on the show. It turns out that he also is doing some important work in cancer treatment. And after a brief conversation, I decided we definitely needed to have him on and talk about what they are accomplishing. Today I have Louie Schoettle, PhD. I'm putting that in. And I'm reading your card and it says Director, Molecular Science Liaison for Caris Life Science. That is a mouthful, young man. Can you help us narrow down what that means?
Absolutely. So normally we shorten it down to MSL. So people may have heard the acronym MSL before. And basically what that means is I am the go-between between the actual oncologists and the data scientists and researchers, specifically for my job at Caris Life Sciences. And what that entails for me specifically is whenever a physician submits a patient's tumor to Caris, we'll profile that tumor, and I can talk about this more later, but and we'll provide a report for the oncologist and the patient, and that allows the oncologist to determine if certain therapies will or won't work for that patient. So I'm the one that kind of helps them when they have questions on those reports. They have questions about, do we test for certain things? How do we test for those things? So with a background in science, that allows me to kind of speak the language of the researchers while also being public facing and helping out with the oncologists.
Awesome.
So I liaise.
You liaise, which is a term in and of itself that we will look up later. But along those lines though, so Caris Life Science is a science organization. Do you do research? No.
Yeah, we do.
You do research. So, okay, tell me a little bit about Caris Life Science. First of all, is it all over the United States? Are you worldwide? How do we,
Yeah, sure. Let me give you the kind of quick history. It's actually pretty interesting. So Caris's chairman and CEO's name is Mr. David Halbert, and he is a very big entrepreneur in the medical industry sphere. He's not a physician, but he is led, launched, and sold more companies than I could count, including currently Caris. So in 2005, Mr. Halbert acquired a company called Pathology Partners Incorporated in Texas. He lives out in Irving, Texas. And this was a company that just did diagnostic work. And diagnostic means that you're determining the type of tumor that somebody has. And a couple years later, tragically, Mr. Halbert's mother died of cancer. And it was kind of during that time when he acquired a second company called the Molecular Profiling Institute, based out here in Phoenix, which was just a small spin-out company from a group called TGen, or Translational Genomics Institute. And both of these companies really sought to help diagnose patients, determine the types of tumors that they had. So after he had those two companies, he combined them under a single umbrella known as Caris Life Sciences. So that's where Caris was kind of born. And then in 2011, he actually sold off the Caris diagnostic side to another company, and then converted what was left into what now Caris has become, which is not a diagnostics company, but rather a Theranostics company. Theranostics refers to exactly, I'll make sure I'll define everything.
What is that?
Yeah. So if diagnostics help you diagnose what type of tumor somebody has, Theranostics helps you determine which types of therapies the patient will benefit from. There you go. So basically, since 2011 on, Caris has been in the business of helping oncologists and patients determine which therapies will work and might not work for them. And this is all based on genomics. So either sequencing DNA, RNA, proteins, et cetera. And I can get into more of that a little bit later. So in terms of Caris's stretch, we are global. We're mainly focused in the US, but we are starting to be used overseas in Europe, in Asia, et cetera. So we are starting to expand beyond that. When I first started about a year ago, there was only about 250 employees or so globally. As of today, there's well over 1,000.
Oh, wow.
I don't know, some people might have seen in the news a day or two ago, but Caris just accepted an $830 million investment from a large investment group. And we're using that to expand not only our sales teams and MSL teams, but also our research teams. So you asked, does Caris do research? And Caris is in what's called the molecular profiling business. And again, that's helping profile patients for the oncologists. And most profiling companies, not all, but most companies will have the business arm, which helps the clinicians in their day-to-day practice. And then they'll also have a research arm. And at Caris, we call that the Precision Oncology Alliance, or POA. You're gonna get a bunch of acronyms today, so I hope you're taking notes. And the POA is, there will be a test later, so make sure.
I don't doubt it.
The POA is made up of over 50 different groups across the country. And some of them are large academic centers like Duke. Others are smaller community practices. And what we do is we offer the clinicians at these practices the ability to look into Caris's database. So Caris has a large database of over 250,000 patients who have been profiled by Caris. And that information, the molecular information, is paired to their outcomes and the treatments that they use.
Okay.
So what we can try to do, and this is referred to as real world evidence, or RWE. And instead of setting up and running a 3-year-long clinical trial, we can actually instantly look at large groups of patients stratified by tumor type, by therapy, and by their outcomes. Did they do well on the drug? Did they not do well on the drug? We can look to see, are there any biomarkers, any genes that are mutated or altered in some way, and see, is that driving why they did well? Is it driving why they did not respond well? And this database is what we offer to the clinicians that partner with Caris on the research side. And there's no cost to this at all. We don't charge a single dime. Caris doesn't sell patient data. We freely give it away to researchers.
Actually, so I told you this was going to happen, and here is our first instance. It makes me think of this particular question. And again, I do ask some dumb questions, but some of them are not bad. So one of the things that I'm wondering is, when you receive a sample tumor from an actual doctor for an actual patient, and you do whatever it is you do, then do you just go to the database and say, oh, it's these 3 markers, here's what we do? Or is it different for every sample? Or could it be different for every sample? And is there a way to distinguish between the two?
Yeah, great questions, all great questions. And they're not dumb. They're some of the most difficult questions in oncology, right? What do we give the patient? Sometimes there's very streamlined organization of lines of therapy. You start with this. If they progress, you move to this, then to this, A, B, C, D. But most often, that's not the case. There's multiple options at every step along the way, whether it's the first therapy the patient's given or second, third, fourth, et cetera. So in terms of once Caris receives that patient sample, we will assess it for DNA. And for that, we're looking things like mutations and insertions within the actual genome, amplification of the genes. We look at the RNA for things called fusions. A fusion is when 2 chromosomes break apart and then join together to create this fused product. We also look at the protein level. So in terms of breast cancer, we assess ER, PR, HER2, PTEN, AR, all by what's called immunohistochemistry, which is when you actually look at the proteins in the sample. So you can imagine you're looking at DNA, you're looking at RNA, you're looking at protein, and all of them tell you something different. And there's 22,000 genes to be looking at. Yeah. So not all of them are clinically relevant, obviously, but hundreds and hundreds of them are. So what we do once we have the tumor type is we know what that diagnosis is already. So again, Caris is not in the diagnosis business, rather than Theranostics. So by the time Caris receives it, that patient has been diagnosed for breast cancer, for lung cancer, for GI, for kidney, et cetera. Now, every tumor type has a different set of drug approvals, has a different set of what are called the NCCN guidelines, which is kind of a step-by-step referendum on how oncologists can treat their patients. And it's not just the tumor type, it's also the stage that the patient is in. Are they in early stage? Are they metastatic? Are they late stage, right? So depending upon the stage, depending on which therapies they've had previously, sometimes we'll receive a patient sample and they've had 3 or 4 lines of therapy, and that can actually alter their genes. You can actually see mutations because a patient has been on therapy. So you need to make sure it's a true mutation and not something that was caused by the therapy. So to just kind of put a bow on this and answer your question, every tumor type is different. Every stage of tumor type is different. And we're assessing it across so many areas. You can understand why oncologists need the help of profiling companies to help them make sense of everything.
Yeah. So really, but the benefit to the other side of it is something that Susan G. Komen is getting into as well, is this concept of big data, in the sense that it's still going to be great to have an ongoing running accountability, correct, of each and every tumor, and then we can start to see patterns. Is that what you notice at Caris? Is there are certain patterns? They're not always 100%. I get that, but it's good to be able to start to predict some of these things, don't you think?
Yeah.
Okay.
Yeah, absolutely. That's literally one of Caris's ongoing research mission statements, is that big database that I was talking about previously. Those are from patients that were profiled by Caris. Now, it's all de-identified. We don't include the patient information, obviously.
Right.
But yeah, just like you're talking about with Susan G. Komen, getting into big data, that's where a lot of this research is going. And a lot of the questions I'll get from oncologists is, why do you seek? Because at Caris, we sequence all 22,000 genes by DNA and RNA, even though lots of them aren't quote unquote clinically relevant. And when they ask me, why do I need all of this information, I ask them, how many genes right now are clinically relevant? And they'll say, let's call it 500. And then I'll say, 5 years ago, how many genes would you have said are clinically relevant? 50. How about 5 years before that? 5. How about a couple years before that? It was just P53, right? Every year we're adding to the list of clinically relevant genes. So we don't know what's important. Right? Especially what's going to be important 5 years from now. So what Caris is doing is we're preemptively screening all of these genes so that when we put them in our database in a couple years, if we find out that some of these genes are important, we'll already have that information for the patients. And we can always do a look back. Absolutely.
You'll actually be able to, and maybe I'm wrong, but what I'm envisioning is you might even be able to see trends that are happening in gene study, correct?
Yeah. So again, that Precision Oncology Alliance, that research side of Caris, it's not made up of just Caris scientists, as I mentioned. It's made up of these participating institutions from outside of Caris, and some of their projects are looking at just that. It's not just over time. Are there differences between ethnicities and socioeconomic backgrounds?
Yeah.
Do we see different outcomes based on, of course, different genetics, but also does the same drug work across tumor types if the tumor types have the same alterations? And we are starting to see major trends that are not just one gene. It's not in the future. It's not going to be, is this one gene mutated or not to tell you if a drug will work? It's going to be 60, 70, hundreds of genes where you have to know information on all of them to really determine if a therapy is going to work for a patient. And this big data is what allows us to create these types of multi-gene algorithms to help just on a clinical report, because the oncologist doesn't have time to look at 70 genes.
Can you imagine? Yeah.
What we do is we'll just give that signature a name, right? You've probably heard of some of these like HRD or LOH or TMB or MMR, MSI. All of those are multi-gene signatures. And then on the clinical report, we just put TMB high, TMB low. That's it. And it makes life a lot easier for the clinician and for the patient when they're discussing treatment options.
So, okay, I have 2 questions. I'm going to start with this one, but the other one I might end up backtracking. Let's start with this one. Well, how long does it take? How long does this process take per patient?
Yeah, that's a great question. It's slightly different for every company, and it also depends upon the amount of information that you're profiling. Okay. If you're literally just looking at ER, PR, and HER2, that'll take maybe 2 days, right? Because you're just running some quick, what are called IHC, some quick protein analyses. But if you need to actually sequence DNA or sequence RNA, that's going to take a little bit longer. So on average, from the second Caris receives the actual patient sample, we're at about 10 to 14 days that we'll
Wow.
return the report to the clinician. So
no, that's way quicker than I was expecting you to tell me. So
yep.
wow,
And it's getting
impressive.
faster. Every year it gets faster because the sequencing technology gets faster.
Okay, now I have another question. So then this is probably silly, but how many people work with each sample? Like, are there 10 people on a team, or is it one person that is in charge of that one sample?
Another great question. And the answer is there's multiple people per sample. Okay. Because again, there are, as I mentioned, DNA, RNA, proteins, there's different types of protein analyses. And then, so most of that is done by the pathology assistants. So these are people who have been trained to run the DNA sequencers, have been trained to handle the tissue samples, have been trained to do the IHC tests for the proteins. Once all of that's completed, then Caris has a team of actual medical pathologists, or MDs, who will actually assess the tests that were performed to either score them if they have to be scored, to sign off on them, to make sure everything is QC'd and looks okay. And they'll actually sign off on the complete report before it's ever sent to the oncologist. And before any of that, there's a whole team of infrastructure teams. So we have the people that do the accessioning and accept the samples. We have the people that prep the machines. We have the people that work on the client services side. So it's a number of people all throughout the process. Wow.
Yeah, that again, another answer I wasn't expecting. Okay, so now this is a two-parter. And I'm going to ask you the whole question at once, and then you figure out if you can and how you want to answer this.
Sure.
How do you connect with either clinical trials or brand new therapies that are coming out? Like, how do you add them into the mix? And then do you end up recommending those if they apply to that particular tumor? Does that make sense?
Yes, absolutely. Again, really great question. So I'll answer I'll kind of answer them in order there. So in terms of clinical trials, they are commonly for patients who have progressed after so many lines of therapy that they're looking for, just an option that is beyond what's been FDA approved. And clinical trials are great. They're literally the lifeblood of oncology because they help us determine new therapies and they help us determine what does and doesn't work. So I'm a big advocate of clinical trials. Now, in terms of how we would recommend them or how we would determine if a patient would match for a trial, Caris has an entire team of clinical trial navigators and clinical trial scientists. And based on the DNA, RNA, and protein profiling that we do, every clinical trial has what's called inclusion and exclusion criteria. So you obviously have to meet the inclusion criteria and you can't have any of the exclusion criteria. Okay. So some of those things are about how well off is the patient. It's called an ECOG score. That's not part of Caris, obviously, but other things are maybe they have to have a HER2 mutation. Maybe they have to be ER, PR, HER2 negative, triple negative, right? Maybe they have to have some type of biomarker that is what's called emerging, meaning there aren't any therapies FDA approved or associated to it yet. So what Caris does is every patient who's profiled by Caris, whether they're ready for clinical trials or not, will get a clinical trial report. And that report is based on the profiling we did for the patient, and we compare that to the clinical trial inclusion and exclusion criteria. We have a team, as I mentioned, who literally every single day will go to the clinicaltrials.gov and then we'll pull off new clinical trials and upload them into our system and feed in the inclusion and exclusion criteria so that when a patient is profiled, it automatically pairs them to the trials for which they're a match. And then what the clinician will receive in the report is a line item, not of every trial, because some patients might match 100 trials, but it'll say for this biomarker, right, ER, right, there's 7 trials that this patient matches. Right. For HER2, there's 9 trials. For immune therapy, there's 20 trials. And then there's a digital portal that they can log on to, click on their patient, and it lists every single trial, where the trial site's located, what the biomarkers are, inclusion, exclusion, et cetera. So Caris does not ever recommend clinical trials.
Okay.
We don't push one, Roche or Pfizer or GSK. We don't do that at all. We just provide all the information, and then we let the oncologist and the patient make that decision.
Right. Which is amazing. That's amazing.
Mm-hmm.
Okay, so you made me, this is what happens. I think of all these questions. So
Great.
are you ready?
I'm ready.
All right. Tell me again, because I know you told me in the beginning, but now I need to confirm this in my head. You guys have only been doing this for how long?
So again, we started off as a diagnostics company a while back, but in about 2011 or so is when we started becoming a Theranostics company. So about a decade.
So you've made some pretty big advances, don't you think?
Oh, wow. Yeah. So from where we started in 2011 to what we're doing today, it's honestly a different company. And a lot of that has to do with advances in technology, right?
Yeah.
DNA sequencing has changed a lot over the last 10 years. So Caris keeps that. We have the best sequencers that money can buy, and we have many of them. It's a large investment, but as you can imagine, with the number of cases that Caris profiles, we have to be able to kind of keep up with that to keep that 10 to 14 day time limit down.
All right. Okay. Next question was, and again, if there's no answer to this question, I'm okay with. Sorry about the cat. Ignore the cat, people.
I'm ignoring.
Come on. So here's what I want to know. Would you consider, and I mean you, not the company, well, yeah, you represent the company. So you and the company, would you consider yourselves successful at at therapies for all cancers, or are there certain cancers that are still not quite as effective? And then how does breast cancer work into that scenario, if that's something you can answer for me?
Yeah, absolutely. And again, this is one of those questions where it's kind of got two parts to the answer. One part's really great. The other part's what we're all working on. So
yeah.
Caris is, and I'm not just saying this as towing the company line here, but we are the most comprehensive profiling company in the market, which means because we do every single gene by DNA and RNA and all the IHCs. So Caris is extremely successful at profiling and providing whatever information there is to obtain from that patient to help the clinician, regardless of tumor type. So we're very good at what we do. Now, the other part of your question doesn't really have to do with Caris so much as it has to do with the different types of cancers.
Right.
And I'll get to breast specifically in just a second. But as I mentioned, every cancer type is different for the drugs that have been approved for those patients, as well as stage, et cetera. And there are some cancer types that have many, many different drug possibilities for those patients based on many different types of, genes or biomarkers or whatever. And then there are some cancer types where there's not a lot out there. It's kind of some of your more traditional chemotherapies and radiotherapies, and that's about it. So those are the cancers and some of the rare cancers where there just hasn't been a lot of activity in clinical trials to even find some therapies. Those are the ones where we can provide all the DNA, RNA, protein information, but if there's not a drug approved, what do you do with that information? Now, the good thing is lots of the pharmaceutical companies have really made an investment in looking at these rare tumor types and more difficult to treat cancers and started to invest in looking for therapies in those areas. So right now, most of that is in clinical trial stages. But again, at Caris, because we profile everything, if the patient has something that will allow them into a clinical trial, we should be able to find it. Now, finally, I'll just finish up with breast specifically. Breast is actually, in terms of the breadth of therapies, it's actually one of the higher. I would probably say lung cancer, non-small cell lung cancer probably has the most therapy indications, but breast is pretty close. Of course, you've got traditional chemotherapies and radiotherapies, but you also have the hormonal therapies, right, for the ER/PR drugs. You also have the androgen receptor therapies. You have the cyclin inhibitors. People probably have heard of like Tecentriq. You have immune therapies such as Keytruda. You've got lots of targeted therapies as well. So targeted therapy is when there is one or a small number of genes that are either mutated or have a fusion, as I mentioned, or amplified. And only those specific genes, if they are altered in the right way, will the patient be FDA approved to be on that therapy. So in breast, you kind of have a little bit of everything, which is nice for the patients to have those types of options if they progress on prior therapies.
Do you guys ever work with pharmaceutical companies? Not easy to say when you've had this much water. For like, I know what I'm trying to ask. Let's say they're interested in coming up with a new cure, like a new therapy. Do they come to you and say, hey, can we see your data? Let's see what's happening in the genome world and help them create new treatments?
Yeah, so again, great question. And most profiling companies will work with pharmaceutical companies in different ways. So I'm just going to speak to Caris because that's what I know. Again, recently with the investment that Caris has taken on, we've actually expanded what we call our BBD, or Business and Biopharma Partnership Team. Now, Caris, as I mentioned, does not sell patient data directly to pharmaceutical companies.
Right.
With that said, we do partner with pharmaceutical companies and are currently partnering with a number of pharmaceutical companies to help them either find patients for their trials, to help them determine, based on our internal data, if a specific therapy should be offered for lung cancer or breast, or maybe it's a tumor agnostic, meaning for all cancer types. So we can help them answer those types of questions. We can also help them to develop a test that will categorize patients as being candidates for their drug. So for lots of these targeted therapies, you have to test the genes or the proteins that their drug acts on. So when they're doing clinical trials, they will always have a company that will do their confirmatory testing. So Caris can serve as that confirmatory testing partner because we do everything, DNA, RNA, and protein, regardless of what their drug is going to target. They'll know that Caris will be able to provide that information. So there's multiple layers to how profiling companies can partner, and Caris absolutely does. Because again, the end of the day is to add to the repertoire that oncologists have to fight cancer.
Right, because you and I had this conversation a couple of days ago. The goal is to get rid of cancer.
That's the goal.
Let's end that, right? So I think you'll find, right, most people are like, let's put everything on the table and figure out how to make this go away. All right, so now let's talk about the other side of it, right? Let's talk about the patient-doctor side. From patient to doctor to Caris, how does that happen?
Yeah, again, so usually it's the oncologist that will drive molecular profiling, so meaning using Caris. But let me kind of give you the whole picture, and then I'll kind of walk you through step by step. So when a cancer patient goes to see their oncologist, they will usually have a biopsy taken of the tumor, if it's possible to get to. Even for blood cancers like leukemia and lymphoma, they'll take a blood sample. And the first thing that the oncologist will do is they'll have that tumor diagnosed. Even if it's a lump in the breast, you still want to confirm that it's breast cancer, right? So lots of times, when it's something in the lungs, it might not be lung cancer, it might be a metastasis to the lungs, right? So they want to have that diagnosed. So they'll send the patient to a surgeon who will take a resection. Maybe it's just like a needle biopsy, or maybe it's an actual, slicing out of the tumor, a bulk resection. And then that sample will be sent to a pathologist at the hospital or at a partnering institution with the hospital. And they will do the diagnosis. Now, depending upon the stage of the patient, most of the early stage cancers, if you can use surgery to cure it, then normally they won't send that in for profiling because you've cured the patient. Now, sometimes there's reasons to, but not always. If it's a later stage patient where the patient comes in and they find a breast lump, but maybe they find it's in the bones now and they find it's gone to other places, right? That's when you're going to send for the diagnosis, and also want to immediately send for profiling, because you know that this patient needs to be on chemo right away. And then they're probably going to progress, sadly, soon after. So you need to know what your options are. So when the tumor sample is at the pathologist being diagnosed, the oncologist can also ask to have some of that tumor sample sent to Caris or any profiling company. So it'll usually kind of happen right after that biopsy. And then again, Caris takes its 10 days or so to profile it and send that report back to the clinician. And then hopefully by the time the patient sees the clinician for their follow-up, right, the clinician will have that report and they can start to make a plan for the patients. So that's kind of the process.
How, I know what I want to ask, but I want to ask it in a proper manner. How does the patient know if the doctor has done that? Is it in the doctor saying, hey, I got this report back and here's what it says?
So I want to be careful here. There's two different types of profiling. There's what's called somatic profiling, which is what Caris does, and that's testing of the tumor sample. Mm-hmm. And there's also what's called germline testing, germline sequencing. And that's when you're not sequencing the tumor, but rather you're sequencing the patient's healthy, quote unquote, normal cells. And to do germline sequencing, you have to get patient consent. Because with germline sequencing, there's also the possibility that now you have to think about children and siblings and parents, et cetera. So the patient should always be consulted for that. Now, back to somatic testing, what Caris does. It is not required to ask the patient's consent, but I do know that I would say a lot of clinicians will speak with the patient upon their initial diagnosis when they come in that first time and they determine it's a tumor. They will tell the patient, it would be smart for us to figure out what you've got, right? What is the genetic makeup of the tumor? Now, there are instances where the patient will come in because maybe they feel a lump and they don't know if it's cancer or not yet. Maybe it's just a cyst, maybe it's whatever. Mm-hmm. But when the biopsy is sent to the pathologist and the pathologist deems that it is truly cancer, if the clinician wants that report by the time the patient comes back, they might just have to tell the pathologist to send Caris the sample for profiling before they have a chance to speak with the patient. So that's when it might happen without the patient, knowing that it's going to happen. But usually they'll speak with it.
I'm worried about the other end of it, where how informed are the oncologists, would you say, in the United States right now about this kind of testing?
Yeah, that is a phenomenal question. It's literally the crux of my job, right? So my job isn't a sales job. I do not go out and sell Caris when I'm evaluated for my quarterly or yearly progress. Sales do not come up. In fact, I despise sales. It gives me crawlies. I can't imagine doing cold calls and reaching out. So let me clear that up.
What about shopping?
I love shopping.
Okay,
I love buying, not selling. Buying is more my side. So what I do mainly is educate. I before working at Caris, I taught at the University of Arizona College of Medicine for their Pathway Scholars Program, and I taught everything. I taught.
Wait a minute. U of A? You live in ASU country, but you taught at U of A.
Well, I got my PhD from ASU, but I taught at U of A. So I'm double dipping. I'm double dipping a little bit.
I'm going to let it go this time.
Okay.
The Wildcats. Okay, sorry. Go ahead.
Sorry. So I'm a teacher at heart, and that's what most MSLs are. But we're teachers. We help educate oncologists. Now, to your question, how well how much does the average oncologist understand about all of this? It is a very wide continuum. So some oncologists, maybe the ones that work at academic centers that are actively doing research, know more than I do. And this is my daily job, right? And some of them have been doing this for 20, 30 years or longer. So there's absolutely phenomenal oncologists out there that know everything that they need to know. With that said, there's also some oncologists who maybe they're out at a smaller community clinic and they're not specialists. They don't just treat breast cancer patients. They don't just do lung. They do everything that comes to them because they're the only oncologist within 100 miles. And God bless them for doing that, right? But you can imagine what I just told you about all the different tumor types and all the different genes and therapies. There is no way one person could know everything for every tumor type. It's just not possible. So we are especially valuable, MSLs are especially valuable for those community practitioners where they are treating so many different tumor types to make sure that when they get a patient's report, that I'll reach out to them if there's something unique and something that they should absolutely be aware about. We'll do prospective outreach to help educate if we need to. So again, it kind of spans the spectrum of some really, really well educated in the field, others that could use, some help to navigate.
All right, so this is a typical direct and to the point question. Is it conceivable that a patient can say to their doctor, I want this done, and that it can happen? Is that conceivable? Can a doctor pick up the phone and be like, my patient says this is going on and they want to be tested, what do I got to do? Is that in the world of possibility?
So the quick answer is yes, but so there's a couple of things to keep in mind here. Molecular profiling, what Caris does, is covered by insurance in certain circumstances.
Right.
When the powers that be, the FDA, the NCCN guidelines that I spoke to previously, they have stratified based on tumor type and stage when profiling should be done.
Yeah.
So at that point, the patient, shouldn't have to worry about costs or anything like that. With that said, if cost is not an issue and the patient is an earlier stage where maybe it won't be covered by insurance yet, if they want the test done and their oncologist agrees to it, then of course, that they can pay to have that done.
Okay.
Now, the one thing I would just put a little bullet point on that is, I don't think it makes a lot of sense to do some of these types of testing very, very early on in a cancer progression, because things change. The tumors can change. So whatever you profile on day 0 of that very first tumor cell, it's probably not going to be the same as what the tumor is going to look like when you actually need that type of information. So there's reasons why the government and NCCN have decided when a patient should be given therapy. Now, those guidelines are slightly moving up because we are starting to see some benefit to some of these therapies earlier on. But yeah, it's usually kind of in those latter stages when you would want to do it.
Which actually makes more sense anyway, because, one of our mantras is early detection saves lives. I say that, I could tell you how many times a day. And mostly that is, the sooner we catch it, the easier it is to eliminate it, right? If it's just a baby, 1 or 2 cancer cells, it's easy to remove, hopefully. And then to keep up on it, obviously. So it would make more sense if you are stage 3 or stage 4 and crazy things are going on, to be just like, all right, what are my options? Do you think that it is, I don't know if it's good for the patient to know all the options, because what do we know? We don't know anything, but it is good for the doctor to know all the options.
Yes. So, and again, just like for the physicians where there's a spectrum of how much people know, it's the same with patients. And again, groups like Susan G. Komen and many others are doing a great job in patient advocacy and patient education. So we're starting to see patients that are more and more trained in these genomic sciences and do understand what the alterations mean and what the therapy for those alterations are. So that's a great aspect to it. The part that you have to kind of be careful with is that when these reports come out and it says potential benefit, so this biomarker is mutated, potential benefit to this therapy, that doesn't guarantee that patient is a candidate. We just telling the physician from the knowledge that Caris has about the patients, right, that they might be a match for this. So the oncologist will always have more information than what Caris does at our fingertips.
Absolutely.
So we just want to be careful that we don't want to hide anything from the patient ever, but we just want to make sure that if they're looking at their own reports, that they don't think it's just a free slate to just say, I want that, or that. The oncologists are the ones who can do the final determinations.
Right. But one of my things, and this is just on a personal level, is I'm not a doctor, right? So if something's wrong with me, I got to go to my doctor. And I got to say to her, because my doctor is a female, hey, here's what's wrong. Here's the symptoms I'm having. Here's my issues. What do I got to do to fix it? And she's willing to try out different things, but she doesn't pick up the phone and call me and say, how are you feeling today? It is my job to go to her and say, I got issues. Let's fix them. And that's what I always am telling our constituents is it's your health. You're the one that has to advocate for yourself. You have to go to someone who knows what they're doing. But if you're not feeling well, or you're under the weather, or something is consistent, like a lump or whatever, you have to take that into your own hands. And so sometimes I'm aware, I love doctors, most of them, and I'm not preaching, to stay away from medicine. I'm all for medicine, but sometimes you do have to advocate for yourself.
Yeah,
and you gotta motivate. You're one of 1,000 patients that doctor has, and they are amazing people, and they went to school for a long time and paid a lot of money to be very good at what they're doing, but they're still dealing with a whole lot of people. So It's okay to say what's out there.
Yeah, absolutely. And just quickly to add on to that, one of the best pieces of advice that, I could ever give a patient would be to ask questions.
Mm-hmm.
Even physicians are very, very busy, obviously, and they do have many patients, and someday they're humans, right? They might be having a crappy day, right? And they're just not feeling it, but they will always answer your questions.
Yeah.
The important thing for patients is to know what questions to ask. And again, that's why groups like yourself and, my position as a medical science liaison is to make sure that the patients know the questions to ask.
So let's talk for 1 second, because I know I promised you a limited amount of time, but I wanted to ask this. How do you end up a liaison? Like, what was it that happened in your life where you went from a PhD in something that I still don't even know what it is? For all I know, it could be auto mechanics, which is okay. That's a legitimate thing. How did you end up there to here?
It's funny. So my dad was an auto mechanic, and I actually wanted to go into mechanical engineering just so I could build cars, but I failed physics, so that was out. So yeah, I mean, it's kind of a winding story, to say the least. As I mentioned, I went to Arizona State for my PhD, but actually before that, I thought I wanted to go to medical school, and in undergrad, I did the whole pre-med thing. I took the MCAT and did well, and got a bunch of interviews, and I kind of backed out at the last minute and basically decided that I didn't want to go down that road. My mom was a physician, and I saw what her work schedules were like and the stress she was under, and I kind of backed out at the last minute. And then it hit me, what do you do with a pre-med degree if you don't want to go to med school, right? Which is the classic conundrum that thousands of college graduates find themselves in when they don't get in, right? So I did what every college basically finisher without a job does. I went and worked at a bar for a year, right? To find myself.
Absolutely.
It was an awesome job. I worked at a dueling piano bar in Columbus, Ohio. It was awesome. And during that time, my mom finally kicked me in the butt and said, I don't care what you do, but you got to do something else because you're not working at a bar the rest of your life. So I decided I want to go back to school, but I had no idea what I wanted to go back to school for. So that led me to, I want to live at a beach. So school, beach, marine biology. So I actually went and did a post-bac education at Coastal Carolina in Myrtle Beach, South Carolina, and spent 2 years there doing microbial ecology and aquatic microbial ecology. And I found out very quickly that marine biology is not swimming with dolphins and playing with sharks. It's doing fecal contamination studies and chemical exposure studies, and I hated it. So after about 2 years, I realized, I needed to switch again. I talked with my mom and I talked with some friends and my advisor at the time, and said, well, you used to want to be a physician. What happened there? And we kind of went down the road, and I realized that I loved all the classes. I loved all the labs, right? But I didn't like the other aspect of medicine, right? The bad part in terms of the schedules and all that. So put two and two together, go into medical science, right? Get a PhD in some type of medical science. So I did. I went to Arizona State, got a PhD in molecular immunology. Molecular immunology, what is that? So hopefully everybody knows what the immune system is after the last year of hell that we just went through. Molecular immunology is the study of DNA, RNA, and proteins of the immune system. So basically, what I did for about 5 years was work on a project where we tried to develop a tool made out of DNA that we could capture immune cell genes with. And the goal was basically to use that information to help design cancer therapies. So we realized very quickly on that there might be some commercial ability to that. And we formed a spin-out company right after I finished grad school. And right after grad school, I took over that company's role of, I was basically the medical science liaison for that company. I did all of the investment meetings. We had business partners as well. But I went to all the investment meetings to explain the technology, to explain the value, the benefits, the need. And then I realized that it wasn't the actual science and the doing of the science that I loved. It was understanding it and actually teaching it. Mm-hmm. And that kind of led me to my position with the University of Arizona. So while I was in grad school, I also used to moonlight to make some extra money. I taught MCAT classes to undergraduates to prepare for the MCAT exam. So I was already teaching a lot of the material that first-year medical students take through those classes, and I taught TA in grad school as well. So I had a previous relationship with University of Arizona where I was teaching just a class here and there for them. So they brought me on formally at that point to teach what they call their Pathway Scholars Program, which is a pipeline for students to get, it's a 1-year master's program to get into their med school. And I taught classes in molecular biology and immunology, et cetera, and cancer biology. And that plus my time with the company kind of showed me I love to teach, I love cancer biology, I love immunology, I love being around physicians, I just don't want to be one. So you put all that together, and that's basically the definition of what an MSL is. And yeah, I was in Arizona. Caris is actually based in Arizona. So I had previous relationships in my spin-out company with Caris, and that's how I kind of made my way to Caris.
Wow. So I'm going to ask you a silly question. Are you smart or are you good in school?
That is the $1 million question, right? I have always been very good at taking tests. Okay. I am excellent at understanding information and regurgitating it. Okay. Now, whether that is the definition of smart or whether that just means I'm good at understanding what I can read. And I actually, the other thing is I actually enjoy it. Like I'll read textbooks, right, from here and there. So it's more of an ability to process than I think any type of inherent intelligence or something like that. I also love to talk.
Yeah, that's and here's the reason why I'm asking. I wasn't being flippant, but your path to what you're doing is kind of interesting. And what I liked about it was that you were lost for a while. Yep. And that is a lot of people, right? A lot of us are like, I don't know what I'm doing. And it's really crazy to me that you ask an 18-year-old to decide what they want to do with the rest of their lives. I didn't figure it out until I was 50. So I kind of feel asking an 18-year-old to do it is crazy. But what I was curious about was there's a lot of people that are probably in that same boat like you, smart, care about the world, interested in, in health sciences, etc. And they're always forced into being doctors because most of the time that's all we think about. But look at how many other careers they are in the life sciences in general that you don't necessarily think about. Yeah. So that was it's a good learning lesson for all of us. Even at 50, if I decided to go back to school, I tell people, I think I even told you maybe, I didn't go to college, so I didn't learn to drink beer. So if I decide I want to learn to drink beer, I may go back to college. But it's never too late to learn something new and to do something great in the world, really.
Yeah, absolutely. And oncology and patient advocacy and molecular science, all of that is such an exciting field, honestly. Yeah. At Caris, we've got new stuff that we're developing technology-wise or other seems like on a weekly basis. And the best part about it is you can get excited about helping people. And that's what, Caris and every profiling company and every oncologist, every advocacy group, the goal, like you say, is just to get rid of cancer. And if you can do that while learning and enjoying it and being out and hopefully back again out in public and educating others, then I mean, I can't imagine a better job.
Yeah, really. Hot diggity. Okay, so I'm going to wrap up, even though in my mind, I do have like 1.5 more questions. One of them being, does Caris have a website? And on that website, can people keep up on what is progressing in the world of life sciences?
Yeah, absolutely. So the website, I think, is carislifesciences.com.
Yeah, and we'll put that in the notes so people can check it out.
Yep, and it's a great website. It has options for patients, for clinicians, and for patient caretakers, et cetera. So
okay, perfect.
There's a great educational portion in there about what molecular profiling is, the different types of questions that you can ask your oncologist about. It's got a great set of webinar videos broken down by different tumor types and different drugs, et cetera. So there's awesome information on there, absolutely, if anybody wants to check it out. Got
it. And what was I forgot my last question. It was silly. It's probably a good thing I forgot it, because I probably would have had to edit it out anyway. So, oh my gosh. All right. So again, we will put all the website at the bottom so people can find you and keep up on what is happening. We'd love to have you back as things start to progress or new things come out. We'd love to be kept in the loop, just so you know. Yeah. So don't forget about us. And if someone has, like really specific questions, do you have an 800 number that people are like, even if it's a doctor, is that something that exists?
Yeah, so Caris has a fantastic group of both customer support and patient navigators and people that they can ask questions to. So on the website, there's a contact list that if somebody just has a question about, is this something I should be asking my oncologist about? There's absolutely people there that can help them. So feel free to hop on there and call away.
Hot diggity. All right, young man, I cannot tell you how much I appreciate you joining us. And we will see you again very soon.
Well, thank you so much. And thank, everybody at Susan G. Komen. I love what you guys are doing. I speak at have spoken at a couple of different patient advocacy groups, and it's some of the favorite part of my job. And it's especially fun when I get to talk to somebody who's funny and entertaining. So you've made it even better. So again, thank you so much for having me on, and I'll be back for sure.
Oh, good. Thank you.